Dear participants, thank you very much for being with us and in numbers. This shows really the interest that the rail community and space community have for the topic of satellite solutions. We are discovering all the challenges and moving forward with our action plan, as I can see throughout this day. So please stay with us, online participants as well. We will now start the second panel discussion, and to discuss the important milestone of bringing innovation to the market and evaluate if satellites are on track. I will now invite on stage Mrs. Léa Pathiès, Senior Program Manager at EUROPE's Joint Undertaking. Mrs. Pathiès is in charge of our activities on train controls and traffic management. Léa, the floor is yours.
Minor size adjustment here, sorry. Good afternoon, everyone. I will be your host for the next hour and 45 minutes. It seems long, it's gonna be okay. We have a lot of nice speakers lined up just here, ready to present on one side and explain the status of the development on the other side. So this is the first technical session. We are going to try and do not make it too technical. We're gonna give you a bit of a snapshot of where we are. For those of you who were in Vienna almost 4 years ago, you might remember that it's similar type of session where we will start with an introduction on the most relevant projects on the side of EUSPA and EURail, and then we will move towards a panel discussion. To do so, I'm gonna call Daniel Lopour from EUSPA. It's going to be a tandem presentation to start with in order to provide a little bit of introduction, a little bit of background. A lot of things will have been said in the panel before, but I think it's good to put things into perspective and into context. Welcome, Daniel, and we are ready to go. I'm going to start with a very excellent question that is on a slide. Are satellites on track? Huh?
Thank you very much, Léa, but frankly speaking, you are always sort of good in putting difficult questions. Huh? I have to admit that this one is quite complex, but also in the context of what we have heard in the previous session, I guess that maybe we should take it straight from the beginning. No? So I would answer to you that indeed satellites are above the track, first of all above. Yeah. Speaking about Galileo, it's around 23,000 kilometers. But then there is also EGNOS, it's even higher above, and it's not moving so fast. So Galileo makes it roughly twice a day around the globe. Whereas EGNOS is a bit more like, a bit more static, not too much orbiting around anymore. And EGNOS is 36,000 kilometers and is sitting there safely parked in the geostationary orbit. And I would say that it's an ideal candidate for a long-term relationship with the railway infrastructure managers for deployment. And for what concerns being above the track, okay, well, we have satellites that can even be under the track. And it's the Copernicus system, which was addressed here before, which can even, for example, monitor soil moisture via radar data. It's actually used, even in Europe. In one of the contributing missions of Copernicus, satellites are used to really determine what is the condition under the railway track. And we are also on the track. And on the track, we are with Copernicus as well, monitoring, for example, growth of vegetation. Or there is a new Copernicus service available to the users, which is monitoring the ground motion. With that, the infrastructure managers can be well aware of the condition of the track, even without the necessity of visiting it from a certain perspective, of course. So, to sum it up, as the executive directors and colleagues from the European Commission and the whole team said, GNSS is widely adopted, indeed, in different operations. We have clear point to make that it is adopted namely in the non-safety critical applications like, for example, passenger information systems. You hardly find the modern trains without the information for the passengers. I mean, just coming back to Czech Republic, I'm from Czech Republic, so by chance there is an application of the National Railway Company which if you buy a ticket even informs you via the mobile phone when you should get out of the train. And that's one thing for sure. And then we have logistics. So it was already mentioned over here that there is a number of railway wagons in Europe that are equipped with the tracking device. It's actually more than 150,000 wagons. It's a large quantity that is already equipped like that. And it's not only used to track the wagons, to provide information to the customers where the wagon actually is, but it's used apparently in many, many different applications, including, for example, billing operation to the customers. So you can, in a better way, estimate the time of arrival of such a shipment or the wagons itself, if they are connected with what is on board. It's possible at the arrival of the wagons to the end destination, to the customer, actually issue and bill the customer faster. So it's even improving the financial conditions of the operations. Okay, so this is a bit of positive news for the beginning, but for what concerns all what I just said until now, it might be quite clear to everyone that having an information when to get off the train, if something like that fails, okay, what can happen in the worst case scenario? You miss your stop and you exit one stop later. However, for the safety of operation, this is a different story, and over there, we are not yet there. And there are some countries actually around the world which made it already. We have to note clearly that, for example, as you see on the slide, we put the positive train control in the US as one of the examples. It is a different system than ERTMS, clearly. It is another range of a system which cannot be fully compared with ERTMS. But still, they made it in the United States to deploy GNSS in a safety-relevant operation, in a quasi-signaling operation. So it is a confirmation that this is possible. For what concerns continuation of the reiteration of the last panel, it has been on the slides as well. The European Parliament made a resolution in 2021, and it pointed out a couple of elements for us in order to keep us focused as well. I put in the bullets that you see there, and I would like to comment a little bit just on the bullets very briefly. So, first of all, the synergies between ERTMS and GNSS. This is something that was pointed out here also by the Commission. This is clear and understandable. But the European Parliament also calls, namely, on the EU railway industry to develop or help with development of technical solutions. And I can confirm that this is already happening. The EU railway industry since years is working together with us in the projects, participating actively in many R&D projects funded by both EUSPA, EU Rail, also European Space Agency, and is trying to seek for the solutions. But where we need to focus more in the future is also to find a common tone between the different solutions that come out of these projects as a result. Because, as Josef was saying before, and also, by the way, Giorgio, what we need to focus on is to arrive at a situation where we have a single solution for ERTMS, and the reason for that is that we need to maintain in Europe interoperability. Then, the Europe actually called on the Commission to consider introducing GNSS in the TSI revision as soon as possible. So, as we have heard also in the last panel, this is something that is fully taken on board, and we are trying to deliver everything to make this happen. And it also calls for a more, let's say, tangible and increased cooperation between the agencies involved. And this is what is on the next slide. It's also actually happening, like in the case of the commitment of railway industry, together with the infra managers and operators involved in our projects. So the close coordination is happening. First of all, we were developing, also with the involvement of the railway sector, cost-benefit analysis. First, our cost-benefit analysis that was done from the technological standpoint, but also the ERTMS users group developed one, which is publicly available on their website, on the site of the localization working group, which is very positively concluding on the benefits that GNSS can bring to the railway infrastructure managers. Maybe for what concerns the next point, Lea, you could step in, no, and help me out a bit.
I am. It was already mentioned during the introductory panel by the executive director of EUSPA, but it's clear that in the new program, GNSS is high on the agenda. It's fully part of the program. We will see in a few minutes presentation from two coordinators of those flagship projects. But clearly, it is again high on the agenda and fully embedded into our technical program.
As a follow-up, we started to participate more actively in the sectorial groups. One of them is also the system pillar, where EUSPA is participating as an observer and sort of gateway to space, in order to be closer to you, to be closer to the railways, to make sure that we can react faster in case of any additional issues, questions that might appear, like, for example, the one stated by Josef connected with the security issues, etc. So we need to make sure that we connect with the relevant experts in each of the area where needed.
Big words are fine, but we actually need to put the resources to the task. I'm happy to at least say that for now there is a high commitment on the side of the rail sector, especially in the Europe's rail program, in order to start preparing the development, to start preparing those activities. It's been mentioned in the panel before, we have big demonstrators planned to happen in 2025 and 2026. Preparation is ongoing, and especially on the providing rail requirements for possible EGNOS service, which is needed for those demonstrators. So we are at the beginning of the work, a lot of work on the table. We are not at the end, but at least there is a real feeling of cooperation and work on the side of the rail sector on this topic.
Indeed, I can confirm that. Actually, as you will see in the next slide, from our projects that were happening in the past, many of these requirements can be derived, but what is necessary is to align, again, at the sectorial level, on the requirements on the final solution that is comfortable for rail in order to feed it into the process of development of the respective service of EGNOS that will be then prepared by the EU Space program. For what concerns also the additional elements that are needed in order to make the story a reality, and by 2030, as it was mentioned, to arrive at the situation where we could possibly have some products on the market, we already started to anticipate a bit to work on the receiver side. In frame of our fundamental elements program of EUSPA, we are funding the development of receiver prototypes. There are currently 2 projects running. They have been recently extended by 6 months, but that's another story. But still, they will deliver their results after the end of the year to make sure that there are some demonstrator receiver sandboxes from where it can be taken on board for what concerns development of a full receiver suitable to work with the new EGNOS service that can be possibly defined and developed for the demonstrators. Yeah, maybe the last point, this was already mentioned here as well, but I would like to escalate a little bit that for what concerns the EU SATCOM, we are actually bringing SATCOM indeed very fast on board of our activities, and it will be one of the topics also of the upcoming user consultation platform. I will spend a couple of words about that tomorrow as well. And now, for what concerns this slide, it's showing a bit more how the research and development ecosystem should be visualized from our side in order to work with some kind of more organized perspective of collaboration between the agencies. And here I would suggest to take it bottom up from the technological driven contribution of EUSPA. We are dedicating significant resources to R&D projects in the area of GNSS in rail. There has been several successful and conclusive projects, like, for example, STARS. Some of you might still remember doing large-scale measurement campaigns. Then projects like ERSAT or Helmet, CLAG, all of these are somehow taking a look at the topic from the technological perspective. However, this is not where the story ends. This should be foreseen as a sort of technological view and a supplier to the layers above. And these I will leave to Lea, if you might help me with it.
I will just add before I continue up in the pyramid, this is just a view. Do not take it as a process. I'm talking to the engineers in the room. This is not a formal process of just to clarify this, because I know the audience. But to continue, I will just anticipate what Frédéric and Alessandro will present. And what I had already said, we have two flagship projects in phase 1 of Europe's Rail program that have started at the end of last year. Future, FP6 Future and FP2R2 data. They will be presented in a few minutes. These are for the moment really the basis for the work on the topic on our side, and high expectations regarding delivery on those projects is currently quite high. Mentioning the system pillar, that's why I wanted to say this is not a formal process. System pillar comes next in the sense of making sure that the solution to be developed, and as we said, interoperable and unique solution developed is mature enough to make it outside of the program. The interaction with the system pillar is not just happening when we have the solution, obviously. There are interactions already now on the architectural elements and so on. That's why I was saying it's not a process. It's just a view and simplified view of the ecosystem, like Daniel mentioned. But system pillar is already playing a big role, will play a big role, important role in the future. Last but not least, and it was mentioned by Giorgio Travaini, is that we're not doing research just for the sake of research. We're doing research so that it reaches the market. And in this case, we're doing research so that it reaches the regulatory framework. And the colleagues from the European Railway Agency will also play a big role in this triangle, into making sure that outside of any discussion on the date, that at least we are making it with the right level of quality and maturity for the regulatory framework documents. Last slide for Daniel and Lea. This is just an overview of the next steps from basically now until 2025, 2026. Like it was mentioned, we're currently in the setup of common working groups. We're working initially on these EGNOS requirements, and it will be done in FP2R2 data, but also globally the general framework of collaboration between the different agencies. So this is ongoing, and hopefully will be closed very soon. Next step will be, well, the actual technical work and preparing those demonstrators so that we make it by the deadline, and we make it with the actual demonstrators that are currently expected to happen in 2 or 3 years. Daniel?
Yeah, I can confirm everything that you say, Lea, indeed. And in fact, it took us a bit of time. I agree that we took to develop the work breakdown structure, but at the working level, I believe that it was a pretty good job, and it's a really consistent way of going ahead and moving towards delivery for the EU rail demo status in 2025, and nowadays we are ahead of an internal process in the agency to review and approve, and then as a next step execute also the working plan from our side. For what concerns the demonstrators, these should indeed be started in 2025, and we will not end in this stage to continue providing support from the side of EUSPA, from especially the engineering standpoint and the consultancies needed, as well as in frame of continuation of our R&D programs. And facilitation of the exchange between rail and space. What I would like to also highlight again, that the most important, in my opinion, job that will be ahead of us is to make sure that we can jointly align on one solution in order to support the vision of one European railway and one single signaling system delivering the benefits that we have foreseen already some time ago, and that we can hopefully fulfill also together with GNSS. Thank you very much.
Thank you. Michel Rosen has a question. No? Ah, for Daniel. Okay.
You proudly presented that you are also now working on EU SATCOM. Interesting. And before we go into details of all the research projects, we also have something called FRMCS, Future Rail Mobile Communication Service. I don't think that you're going to talk about that today, because it is differently organized, but can you give us a little bit of an indication of whether SATCOM is also going to be then integrated in FRMCS?
You open up a wonderful box, Michel. There's mixing two.
And I thought that you are the worst. No? No? Okay, so FRMCS, what is it? Future Rail Mobile Communication System. Am I right? Yeah. You confirm? Okay, so let me give you a little bit of perspective. Similarly, as in case of GNSS, at the space program, we work in a way that before producing any kind of service, we start with the collection of the user requirements. I slightly touched the base on that before, and I thought to elaborate a bit more tomorrow, but already now I will announce it. I can say that on the 7th of November, you are all cordially invited. There will be a user consultation platform of EUSPA happening in frame of the EU Space Week in Sevilla. And over there, for the first time, we will open the floor also for Copernicus and SATCOM. And I would really like to ask you, Michel, and all the other potential contributors for your help, because it's over there where we would like to have a first kind of food for thought. What could actually be the requirements on SATCOM in the context of FRMCS that we could possibly, or not possibly, this is still to be seen, deliver. And this is something that should start as soon as possible as the debate, because as you might have seen, and it will be reiterated also tomorrow, the schedules of IRIS² are quite tight. And therefore, I would kind of like to jointly cooperate with you in the same way as in case of GNSS on elaboration of these requirements as soon as possible, so that we can link it to the ongoing work. And to be frank with you, we are not fully orientated from the side of the space program as of today of what could be the concrete space for IRIS² inside of FRMCS, but we are happy to help and would like to hear from you what could be the way forward. I trust that I informed you conveniently.
Thank you very much. No more question for now. I mean, we have a packed agenda, but it's still a democracy. So one more question, otherwise then we move on, because the 4 presenters are lined up and eager to come and present on stage. Okay, good. José Bertolin will be the first presenter of project's results. He is coordinator of CLUC2, project financed by EUSPA, and he has a few minutes to present you, a few minutes, to present you the results of CLUC2 and how it is relevant in the context of this discussion.
Thank you, Lea, and thank you, Daniel, for this good presentation. I think that I can tell that based on the presentation that you have done, we have a good spirit between ERGU and EUSPA. So this is a good first step in order to go forward. But I would like to make your words also mine regarding this integration and this collaboration, that it is an important message that we have to emphasize. I will come back afterwards in my slides. But probably CLUC2 is a good example of this integration, because basically CLUC2 is taking information from Shift2Rail, outcomes of Shift2Rail, in order to improve something and to continue later in ERGU. But, okay. So just a brief summary of the project. The project started in February 2023. And now we are in the 7th month. So for the time being, we have progressed a bit, but just in requirements and user needs. The duration will be 24 months, and it will end in January 2025. The consortium is mainly constituted by relevant stakeholders in Europe, in the space, and also in the railway sector. The project is coordinated by UNIFE, assisted by SNCF as a technical leader, and administratively from RINAC. As you can see there, we have 3 of the main infrastructure managers in Europe, DB, SNCF, SBB, and also very relevant manufacturers in the rail sector, Siemens and CAF, and in the space sector, Airbus and Syntony. And finally, we have a representative of the academia, ENAC, with a big expertise in the GNSS sector. Oh, we cannot read the slide. It is a pity, but okay, I hope that I can manage it. So basically, as I said before, the project CLUC2 is a continuation of CLUC 2.0, is a continuation of a previous project called CLUC, where most of the partners in this second project were involved. The main objective is to demonstrate and to complement the ETCS odometry system, and in this case, through a onboard EGNSS plus EGNOS based multi-sensor fusion algorithms to contribute to the absolute safe train positioning plus navigation, also considering a new paradigm for the train positioning, how it is computed today. So basically, we cannot understand, this is the main objective not only for CLUC, also for CLUC2, it's the global objective of these initiatives, and we cannot understand what CLUC2 is doing without CLUC1, because honestly, CLUC2 tries to go a step forward in the maturity of the outcomes obtained in CLUC1, and also to increase the tier level of this. So basically, just a few words regarding CLUC1. It is mainly dedicated to 2 objectives. One is the multi-sensor fusion approach to demonstrate the feasibility of this solution, and also to the safe functional architecture using the GNSS plus EGNOS. For that, the consortium counted with simulation analysis, also with a measurement campaign to obtain sensor data, and developed localization functions in order to post-process the data, and also a first proof of concept of the safety functional architecture. Finally, they perform a RAMS analysis in order to assess the safety level of all the functions already developed. So what is new in CLUC2? So continue with the activity already performed. They will complement and consolidate the user requirements and the user needs and the system requirements already developed in Cloud 1. Also tackling not only the alone track, that was the functionality performed in Cloud 1, also the track selectivity and the startup missions. Also, they will consolidate the architecture defined in Cloud 1, and they will prototype new functionalities. As it is right in there, the track selectivity and safety, also the fault detection exclusion algorithms, the confidence interval computation, and the global integrity concept. The runs will be improved considering the new architecture that we will define, or the adapted architecture that we will define in Cloud 2. And finally, everything will be live demonstrated and replayed in Switzerland in some test train. So basically, Cloud 2 wants to go in a higher TRL in order to achieve the next step. Just my last slide, I need to emphasize the message at the beginning. And this is a clear example of a project that it is linking different agencies. So Cloud 2 is taking information from previous EUSPA projects, like CLAC, for example, because it is the continuation, but also EGNSSR, but also X2Rail 5, that it is a project coming for the previous program of Shift2Rail. And the outcomes are going to feed R2Dato, and the main objective is first to demonstrate the feasibility of the GNSS use in the signaling solutions, but also to validate and to contribute to the future standard. And in this case, it has been mentioned before for many speakers, the future TSN releases. So this is all from my side. I hope that I fit the time. In any case, Perfect. It is very brief. So we have a web page, we have a LinkedIn, and you can also contact me if you are interested in this activity. Thank you very much.
Thank you. Yeah, thank you, Jose. Unless there is a very, very, very urgent technical question, I would suggest that we move on to the next presenter. My dear, Francesco will present the EUSPA project Helmet. I suggest that we move on in order to have a bit of the full picture, and if we have a bit of time at the end of this small session, I'll allow some questions. Floor is yours.
Thank you. Thank you, Lea. Thank you, Daniel. Good afternoon to everybody. I will move on the Helmet project. Helmet was a project funded by EUSPA, and which has been recently concluded, and which was conceived as a multi-sector project, tried to combine the needs of driverless cars, train management system, and drones flying above the railways for transport, for logistic reasons, or for just for surveillance. The important starting point of Helmet was to use EGNOS as it is today, Galileo and local network, and use also the new standard messages which are being standardized by the committee, the RTCM committee, where all the manufacturers of GNSS receiver are contributing. So this will be a new class of receivers conceived for integrity and for accuracy. Synergy with the automotive application. There are several years that we discussed these things in the conference, that we have to look to the automotive sector. I took one slide from ERA, which was just presented at the Helmet workshop, where this synergy was shown as an input to try to capture from the automotive sector the technologies which have been developed or being developed. Of course, the automotive sector is so big and having a so big challenge to detect the car position very accurately, that the products that are being launched are very, very competitive. And this can be, of course, a source of inspiration of reusing for the car. More recently, the European Commission has released the directive where it is mandatory to adopt for the new car by 2026 the ESA, the Intelligent Speed Advisor, which is a concept very similar to what is used to ERTMS, to advise the driver on the maximum speed that has to be taken. And this, the important thing is that the European Commission has said that this challenge has to be fulfilled, combining video, so the video sensor, with GNSS. So all the manufacturers, the big tier one and the car manufacturer, are now working on this new class of sensors, video plus GPS, GNSS for the ESA. The other important message in what we have achieved in helmet. First of all, we have worked on the augmentation network, trying to develop a layer to achieve the integrity and the accuracy which is needed for rail and for automotive and for drones, reusing what exists, EGNOS. There is no need to have new augmentation network, and trying to share the infrastructure, especially for the telecommunication 5G and for the GNSS augmentation with the car manufacturer. In Italy, there are already 300 kilometers of smart roads which have been deployed by ANAS, which is part of the group Ferrovie dello Stato, FSI, which is already deploying this solution, and inside this tower there are already communication systems. Now, I want to show you the results we achieved, some of the results we achieved on the helmet project. In this table, you see what are the service level which will be implemented by this architecture. Service level 1, 1A and 1B are already achieved. I mean, there is no need to make further technology steps. These are already available. And what is important is that we started and we have shown the use of EGNOS V2 with ERTMS local network in 2015 with ERSAT EAV. Joseph remembered the demonstration we did in Sardinia. So 8 years ago we have demonstrated the concept. Now we have the results. So the results show that we can achieve accuracy at the protection level which is needed for the ERTMS in the range between 5 to 25 meters, and this can be further improved up to 2.5 meters. So 2.5 meters are now, I think, is a number which is achievable. The other, which are sub-meter accuracies, are for the automotive sector. Now, performance, we did a long test campaign in the test bed of RFI in Sardinia, and we have compared the performance achievable with EGNOS, GPS and EGNOS, and with the performance achievable by adding also Galileo. So you see that the difference is important, is impressive, because with only GPS and EGNOS, we are, the accuracy is below 10 meters, respect to 18 meters we tested in Sardinia in 2015. But with Galileo, we are lower than 6 meters, and the 2.5 meter is now achievable. So this is without making other technology developments. Looking behind the helmet, even if the project has been completed, we have identified the key issues that need to be done. First of all, the certification and the safety case for the mature augmentation tires. So we started with the model of the aviation that is for rail is simplified, and now we are going in this direction. Deployment of a test bed. This will be the next tangible action in Italy, and a project will be started very soon, and this test bed will allow car manufacturers, but also train operator, infrastructure manager to use for making the test. The other important message is that we are extremely convinced that the virtual testing is a priority, because especially now that I learned this afternoon from Joseph Doppelbauer that the new TSI is conceived in a modular manner. This means that the localizer has to be validated as a self-standing solution, is identical as in the car. And, and for that we are realizing in Italy, in the Abruzzo region, a laboratory which is called the PCAR, together with ESA, that will be used to validate these multi-sensor solutions. There are other improvements we need to be done, among the others cybersecurity, which is very, very important. And I think what we did and what we plan to do, of course, is open to Europe Rail, to the continuation. Thank you very much.
Thank you. Thank you very much, Francesco. Suggest we proceed with the next presentation. I'm trying to keep a bit of rhythm here so that we catch up a bit on the delay and have enough time for question and the panel discussion. Introducing Frédéric Villot, the coordinator of FP2 ERTMS, yes, one of the flagship projects of Europe.
Thank you very much. Good afternoon all. C'est le vert? Non, c'est gros bouton vert. Yes. Just a quick presentation of ERTMS. Budget 160 million euros, so it's a big project. Grant amount 53 million euros of subvention. And we started in the first December of 2022 and we will end in May 2026. We have 28 members, let's say 13 industrial, 12 railways, and one international organization and 2 research institutes, and that's it. It means it's a mix of industry and railway operators, and that's a key point to develop a good solution. What is ERTMS? Just because it could be a strong acronym, but it refers to Star Wars because we want to play the future. And Star Wars is a key example of what the future could be, at least at some point. So ERTMS is planned to develop the future European train, future digitalized, automatic, on modular train on digitalized infrastructure. All words are important. And it's displayed in the structure of the project because we have automation process to look at how the train can be automated. We have optimized headway, how we have more train on one track. Enable digital technology, how we can put digitalization at the most on the railway sector. And fast effective deployment is a key point mentioned by Marine, that as deployment is very difficult in the railway, and so we have to tackle this point now in the phase of research. And finally, the next step, we're preparing the next step with innovating operational solutions with self-driving wagons, virtual coupling, and autonomous rail setting, okay? And these are technical enablers. We will develop this technology, and I will highlight the TE2 train positioning. For that, we will need satellite. When we built the program, we started with GNSS only, and then in March, the EUROPE provided us an opportunity to work with ESA and EUSPA, and after a lot of discussion, we came to an agreement inside the consortium that we will modify our work program and we include EGNOS in our development. So thanks to ESA and EUSPA, let's say, window open or door open, we will work with them, and we have a lot of work, and we will go for that after. And just to finalize, we'll go for demonstration, but demonstration on train, and we have 8 demonstrators. Let's say freight, regional, urban light, main line, onboard platform. This is what is a simulation one. It's a virtual one. Moving block, hybrid level 3. This is simulation only, not real. And stabling and shuttling, it will be a real one with NS. This one. Why do we need this diagram? Is from Klug, so we did not work at the moment. Just to be clear, it's not air-to-data production. It's let's say the basis of the reflection on how to include EGNOS and GNSS in our infrastructure design. Okay, and just to explain why we need EGNOS and where it feeds into the system. Okay, but it can be reworked, it's not finalized. We have Klug 2, and we will also work in it, and we'll converge on one final solution. But let's say the starting point. And then after, let's say, 3 months of discussion with ESA EUSPA, we agreed on this work background structure that was introduced by former presentator, sorry. And so let's make it simple. We will go for requirement, then roadmap and certification at the main stage. First set of requirement end of this year, second set validated end of next year. Go for demonstration, for device demonstration of localization, including EGNOS, in 2025 to reach the deadline that Giorgio mentioned. All demonstrators should be ready in 2025. Just to be clear for everyone. And why do we need EGNOS? And because we need to put localization on the train, because it removes localization on the track, so it will reduce the cost of the system, but it will increase the cost of the operator. So we have also to have a word between operators and infrastructure manager, how we split this increase and reduce of costs, and it will be part of the discussion. So for A2Data, what we want to develop, a common safe solution, accurate, and we want to absolute safe positioning to increase capacity, because when I explain the acronym of A2Data, what we want is to increase railway capacity, because what we are convinced is that the, let's say, crowded area of Europe, you cannot build new infrastructure. So the only way to expand train is to make more train on the existing infrastructure. And for that, we have to reduce headway. And absolute safe positioning will help us on that. And we will have to implement localization on train with increased level of accuracy and RAMs, reliability, availability, maintainability, and safety, just for everyone, just to be clear, because it's an acronym. And for that, we will upgrade 6 of the 8 demonstrators of localization with EGNOS by 2025. And if possible, this is not a commitment, it's an option, we will include them in 1 or 2 of the demonstrators I mentioned on the slide previously. And in conclusion, yes, the railway sector has expectation of collaboration between rail and space to use this technology, let's say, at a lower cost, because it's existing technology, it's adaptation, you don't have to develop something new, and it's a big opportunity to make it fast and, let's say, effective. Thank you for your attention.
Thank you. Some movement. Thank you, Frédéric. Please stay with me. It's almost over for the presentation part, and then the panel is almost ready to go. I'm going to use this one. Last but not least, Alessandro Massis, the coordinator of FP6 Future. It was addressed earlier this afternoon, business needs related to low density lines, and he's here to present what the project is about to do.
I will use this one. Okay. Thank you. So hello to everybody. Let me start with this presentation. So basically, I represent the project, flagship project 6 Future, which means future for the regional rail. So it's a quite ambitious, let me say, acronym for this project. So just little data about the project. Is a 35 million euro budget. We have 21 funding members, representing all Europe and many affiliated entities. This is, I would say, it's a little sister project of the flagship project 2 just presented by Frederick, because this project will use a lot of technical enablers developed in flagship project 2. So Frederick, yes, you have a responsibility toward us. And what is very important to say is that, the regional railways, so the low density lines, secondary network, they play a crucial role. Not only, there was some problem with the graphics importing it, so you cannot read, but basically the point is not only to serve the regional passengers, but also as a feeder for the passenger and freight traffic in the main core network. So why this is important? Because if somebody thinks we don't care so much about these regional lines, if they will be gradually, as it is unfortunately happening, dismantled, this will also affect the freight and the passenger mainline network in terms of services and number of passengers. So this is critical. So this project is basically focusing on what can we do to reduce the cost for these regional lines. And at the same time, exploring the new technologies, at the same time also improve performances, capacity and so on, which, in all sectors it happens, So new technology, lower the cost and increase performances. So the goal is to increase the efficiency, and to tackle this problem, we divided, the issue into two groups of regional lines. The biggest one, where we are putting more funding and more members involved, is the regional lines that are physically or functionally interoperable with the main network. So in this case, of course, if we are looking for cost-efficient solution, but we need to ensure interoperability. So that's where we have a strong link with the flagship project 2, because the solution there will be applied in this group 1 line. The second group are the ones that are even at more risk, because these are the more remote lines with low density that are normally not physically or functionally interconnected with the main line, where we can relax the constraints of interoperability. Of course, we have a goal to keep standardization, ensure that the solution is standard, but we don't have the constraints of interoperability. So basically what we are doing, as I mentioned, on the regional group 1 line, we are working in strict cooperation with flagship project 2, providing demonstration site in the regional lines, requirement and use cases to apply satellite positioning to the maximum extent possible to reduce the cost of the wayside equipment. And one of the reasons also the regional line are interesting is because they clearly represent an easier environment to apply the new technology. And this is because, of course, the performance requirements, I would say even the safety requirements are less demanding, not because we can allow less safety, but because it's easier to allow safety when you are less trained, more distance, so the precision can be less, and even the communication. Then when we go even to the regional group line, when we can even consider more radical approach, where satellite technology are not only for satellite positioning, but also for the satellite communication. In the discussion today, somebody was making this question, can we use communication also in the future mobile railway communication system? For sure, but the point is, in this low density line, we can test this solution before, and in an easier way. And this can be basically an enabler for the application also in the main network. I would like just to end with a message that we think that Galileo and EGNOS program are really key elements to allow not only the European railway to evolve toward more efficient operations, but also an opportunity for the industry in EU to develop advanced solutions. And this because this solution, low-cost solution for regional lines, can be extremely important also in other continents worldwide, where we have a low-density line, but absolutely strong need of cost-efficient solution. Thank you.
Thank you very much. So, we're a bit delayed. I would suggest that we call our panelists on stage right now. So for those of you in the audience, you can stretch a bit. We are not done, but the interesting part is still continuing. So I'm calling Stéphane Calais, Head of CCS-related innovative projects at SNCF. Thomas Gugler, Technology Program Manager at SBB. Thomas Laux, Lead of Digitization Rail System at Deutsche Bahn. Ivan Lopezegui, Software Engineer at CAF. Vincent Passot, System Innovation and Onboard Solution Director at Alstom. Fabio Senesi, Senior Executive Manager at LFI. And last but not least, Antonella Trombetta, Director of European Affairs at Hitachi. Welcome. Get settled, you have a bit of time. While hopefully the people at the back are not suffering too much from the heat. If so, very sorry, but indeed, go like this. All right. Good afternoon, everyone. I will try to find the optimum microphone position to my position so that I don't destroy everyone's ears. To sum up, since the beginning of the afternoon, we've discussed about innovation, we've addressed competitiveness, we've addressed cost savings, we've addressed efficiency, we've addressed ETCS deployment, we've addressed interoperability, new TSI, safety, accuracy, reliability. Yes, I'm throwing everything out there. But we've addressed already quite a number of important elements when it comes to the integration or implementation of space technologies into the rail system, especially when it comes to a safety function like positioning. Very quickly, I'm going to ask all of you very snappy response, only a few seconds so that we can get moving to the rest of the questions. What are your thoughts about the current situation, about what has been already presented this afternoon in the panel before, but also what has been the achievements that have been presented by the projects and expectations on technical activities that are upcoming in the Europe's Rail program? Stéphane?
Yes, thank you, Leah. Good afternoon, everyone. And thank you to the four speakers presenting this four project. I will start from this point with those presentation. My impressions is that we have, first of all, progressed a lot in terms of knowledge, demonstration of the usage of GNSS in the railway in the past years, and that's very nice to hear from our colleagues here and the speakers. We have progressed, and we are now tackling the right topics, I would say, for application to the railway. Typically, the presentation we saw, first of all, that we are tackling the issue regarding safety. There is no, let's say, train localization application in the railway without safety, and I think this is very important that we are all aware of that. And the second point, thanks to R2DATO and Future Rail presentation, Europe's Rail presentation, we see that we are tackling the system-wide approach. It's not just positioning for positioning, but I think we are just dealing with the right topics. So thank you for that. And another point, a second point, is also that we are bringing stakeholders, the right stakeholders, in this kind of project in terms of knowledge, capabilities, suppliers from space, suppliers from railway, operators, academics, and that's very fine. And we are also doing this in the frame of Europe, not just on the country level, because we are focusing on an interoperable system at the end. So these are my main outputs, my takeaways from those presentations, and I'm very happy of that.
Thank you. Thank you. You've summarized already quite well the situation. I'm going to mix things up a bit just so that we get the panel a little bit movement. Fabio, can I ask you a very short, snappy answer to your gut feeling at the moment, and then we enter more into the situation in Italy later on?
Yes, thank you. In Italy, we are realizing thousands of kilometers of ERTMS, and in 2027 we expect 7,000 kilometers of radio-based system, adding high-speed lines, corridors, and also regional lines. So it's clear that when a train expects the balise, if there is any problem of radio system, with several GNSS on the sky, will be obvious that a virtualization of the positioning is something that is needed for operation. It's not at the moment a need for trial, is a need for passenger. That's why we expect a lot from the new TSI, including the virtualization of the balise, that at the end I think is the unique engineering solution, because ERTMS is a project with a linking of positioning. Is the core of the philosophy. So the positioning, I think, will be expected in Italy in 2027.
Thank you very much. Ivan, keep you on your toes. What is your initial snappy thoughts?
Yep. So I think the important step we are making here from the last 4 years is that we now realize we need a fusion algorithm to go forward. And in this fusion algorithm, we have put all the inputs now in air-to-data, having this ECNOS input from EUSPA. And that has always been either we use ECNOS as it is from signal in space, and then somebody is doing a black box to bring this one into the railway. Or now we are really tackling and requesting EUSPA. Give us the real interface to this ECNOS, which could be applied to the fusion algorithm in the railway. And that's a crucial step for first, checking out performance. And I think this is where we are right now. We're checking out performance, and then with inputs from EUSPA, we'll be able to guarantee safety. But performance has been a critical thing. We have always simulators, we have always stuff done, but now we are in a specific case. In the next 3 years, we'll be able to actually see the real performance of this one. And with performance, then you can start thinking of safety, architecture, interoperability, but real cases and real demonstrators with real data. And that will be crucial. So I think we are really hoping in the next 3 years to have really good information.
Thank you. Let's go to Thomas Lux, because we have two Thomas on the panel, so I need to be careful. From Deutsche Bahn.
It's often the case in Germany. You stand on the street and say Thomas, and everybody turns around. Actually, I have a bit of a confession to make. Up until a few months ago, I didn't really think about like satellite positioning or satellite use in railways, just because it wasn't my job. And then we started about shortly after taking over the role. We talked about appliances or application of satellite positioning for the railways, and it took me all of 5 minutes to be convinced that this is the way forward, because just taking like the big picture or the satellite view, pun intended, what we have been doing as a railways in past years and decades is taking things out of the track side or away from the track side and putting in the vehicles or putting in a central location. We're doing this with interlockings, we're doing this with signals and many more things. And of course we did this not only for fun, but because it increases capacity, quality, thank you, cost efficiency and so on. I'll just take this. And today really just reinforced this conviction that things are not only in an idea stage, but things are going to work, and we need this to work, and we need this to work a bit faster than 2030, but I'm really convinced that it will work.
Good, 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 good. Optimism is good. That's good. At least because there's a lot of work ahead of us, and I think we've provided a snapshot, and like I said in the introduction presentation, the rail sector seems to be committed for now, and it would be good to keep this momentum so that we actually deliver on time. Now, let's see, I see some desperate side. I guess someone doesn't want to be last. No? Antonella, go ahead.
Okay, so I'll leave once I have the last one. No, in terms of, let me say, the snapshot of the current situation, I think that, of course, the satellite already demonstrated its high potential in several sectors and its readiness in many of them. What happened in rail? Why we didn't apply satellite before? I think that we needed to face two different aspects that more or less are at the two face of the same. First of all is the fact that, as already mentioned, we need to base also the satellite technologies on ERTMS. And up to now, we put a lot of effort in the definition of ERTMS and in the deployment, and we need the deployment of the ERTMS in order to have on top all the new technologies and not only satellite. The other one is the fact that because of it will be based on the ERTMS, we need standardization, and so we need to all agree on this, and in this case we have all the stakeholders that are participating on it. I think that now the situation is going on. We reached a lot of good results in the shift to rail. 2 projects has a satellite inside, and it makes a very good basis for the Europe's rail. I think that we are in a good path.
Okay. Yeah. Thank you. Thomas Gugler, Switzerland. What's your very quick thought on the situation, and then we'll dive into it.
You asked me to analyze the current situation, and the best thing to do is look back. So, as ERTMS user group member, I remember the letter we sent to EUSPA to launch the activities, and the activities started, they take place, as we see also for the future. Also, currently, as we are speaking in Switzerland, we have trains equipped with test equipment that are running in service, in commercial service, gathering data which we can use for the algorithms we want to test or for the digital map. So from this point of view, we are on a good route, I would say. But of course, small projects national-wide are good for a fast maturity, but not to implement a technology European-wide. So this is also a good point to say that all these programs that are ongoing, Europe's Rail, also Air2Data, as we see, are the right platforms to get these standards together and to stop the segmentation that we also heard today, which is a problem in the railway sector, and have the common European railway area.
Thank you. Last but not least, Vincent, your opinion?
Yeah, good afternoon. So as a short answer, I'm very excited from everything that was said today. Though if I want to elaborate a little bit, the question was, where are the satellites in relation with railways? Just to remind that there have been already pilot projects 15 years ago in the south of France. Of course, at that time, availability of the services were not the same, availability of the ships, the price were not the same. But what is important is that we saw this afternoon that there are important building blocks that have been created. We mentioned about Club, we mentioned about Helmet. You see that in Helmet that even the service of augmentation are getting more and more accurate in terms of location, but also in terms of level of security or integrity we can achieve for that. At the same time, thanks to other sectors, commercial available ships with high level of performance are also readily available from several sources. And also we are seeing that there are no very strong collaboration between all those players, including 2 major European agencies. And we do not want, I would say, to reiterate a little bit the GSMR industry where we create a variant for a small sector, so we better rely effectively on service technology which are developed for as much user as possible in order to make sure that new feature, new performance, cost reduction, services are available, obsolescence is properly managed. So there are effectively steps which are already there. I mentioned France pilot project 15 years ago. For the time being, as we are speaking, so Alstom is deploying in Norway on 450 trains satellite satellite localization as well to increase odometry, not because we want necessarily to have performance, but in these countries, the snow conditions in winter are as such that traditional speed sensor, radar Doppler are simply ineffective. It's a first step. We are still using for that project what we call relative odometry, but there are also pilot projects in Spain and Italy to effectively perform absolute localization. And of course, in the frame of RD2 Dato, we are also going to participate to further demonstrator, taking benefit of further performance, further development on the product, and also taking benefit of progressively standardization to make sure that the benefit that interoperability brings with the ERTMS are not jeopardized and we can capitalize on them. Thank you.
Thank you, Vincent. I'm going to take this opportunity to open up for questions from the audience. So if you have a question for one of our panelists, also if you have a question for one of our presenters, we can always go back. But if there is any burning question on your lips, it's basically now. Otherwise, I continue. Okay, I continue. There is one. Sorry, I didn't see you.
I have a question regarding the solution. Do you consider an onboard solution or also a trackside solution? Because we have heard in the previous panels that it will be onboard investments. But what about, for example, the track sites in the situation, for example, when the train would go through the tunnel and then there would be no signal? Or in areas where it would be, like, for example, in many mountains and the signal could be weak? Thank you.
So, from an operator perspective, I mean, what we want is safe train positioning, and we don't want just one sensor. There is multi-sensor fusion, and exactly for situations like in a tunnel, we rely on other sensors than, for example, as we are on an open field. So it's not just satellite-based localization, but rather multi-sensor fusion.
Anyone wants to add something? Yeah, Stefan.
Yes, thank you for Thomas. I totally subscribe to this answer. I think also we are convinced at SNCF with the different projects we were involved in that inertial is also a part of the solution in this multi-sensor approach. We have, yes, a GNSS which gives you an absolute localization or relocalization of the train. But as you mentioned in your very interesting questions, we lose contact from time to time, yes, of course. So we need also approach for other sensor. Inertial is interesting because also we are completely independent from the axles of the rolling stock. It's not completely the topic today, but it's all, yeah, I just mentioned it because it's part of the solution, of course, yes.
I'll just round out the infrastructure manager side of the answer. I also fully subscribe what my colleagues just said, and just answering to your question regarding like a general statement, apart from like special situations like tunnels. From my point of view, a vehicle solution is preferable to an infrastructure solution. We have way more kilometers of infrastructure than we have vehicles. And regarding like maintenance, reliability and so on, usually I'd veer to the vehicle side. There is, of course, the problems to solve, like for the installation of the necessary sensors, but I think we will get that solved.
One last point to mention to what Stefan also said. Digital maps are playing a key role in this solution, at least in the ones that we are planning to have in Edge Data and Klook. So that means GNSS plus ECNOS is an enabler, but the other sensors plus the digital map are playing also a key role. And that's something we are discussing how to deploy that. And that's, of course, something that should be brought by infrastructure managers to the onboard side.
Fabio, you want to react, or anyone else? No? They've covered pretty much the answer. I hope you're happy with the answer you got. Yeah. Also the proof that there's still a bit of work to be done on the harmonized solution. There is another, I'm told, yes.
Yes, I would like to raise a question to suppliers, and maybe railway infrastructure manager, you can comment. Joseph Doppelbauer made a statement, quite interesting, that by 2030 we will have the product. We shall have the product. So, as suppliers, will you be ready to sign contracts in 2027? And the second question, I will speak also afterwards. What are the savings that you provide to this? There's been a big discussion about the cost doubled, I think, in the last 5 or 10 years in ERTMS in Europe. Everybody was expecting to be reduced by 50%, but they doubled. I think this innovation, what savings will bring to the system. And I would like to hear also, maybe if there is any comment from the clients, happy to hear us.
Yeah, so I believe the question is for the supplier. So the first question, as I mentioned, so we are already have a product or component which are deploying on the train. So I have no doubt that effectively by the date that Joseph committed in the name of the supplier, we will have effectively product that, yeah, but your dreams are sometimes becoming our nightmare, but anyway, so joking apart, yes, it's already the case. So we are effectively following. Of course, we are not manufacturing ourselves the receiver or the chips, so the suppliers are more there effectively to bring, I would say, the typical railway environment in terms of how data fusion between various sensors is being performed, what are the various algorithms we are making there based on effectively specific topology or rolling stock element. There are immediate savings. In the case of Norway, I was mentioning, putting a GNSS receiver in comparison with a Doppler radar is obviously less costly. The receivers are cheaper. There is no need of brackets. You don't need to have effectively to put your train on a pit to maintain, to recalibrate. There are no cabling which are subject to damage. And usually even the GNSS receiver is already on the train because we need to have a centralized clock for a juridical recorder. So we are virtually offering effectively an additional feature of localization or navigation without additional or very little equipment on the train in comparison with traditional means. Now, obviously, if we are looking in the regional market where we say that having very accurate submeter, we mentioned value of the train allow to significantly reduce the infrastructure element. And when I say submeter, because it's allowed to have the distinction if you are on the left on the right tracks, you don't need to complement by the wayside. Obviously, there is no specific major cost saving on that train for that purpose. And I understand that from the infrastructure manager, they will want to push the cost of the operator. If we speak to the operator, they will say the opposite. But obviously, there is a major saving in that respect. Yeah.
From point of view of infrastructure manager, it's clear that ERTMS and evolution transfer technology from trackside to onboard, even for satellite application. But it's not only the regional lines. Imagine the project high density hybrid. When you want a section every 200 meters, 300 meters, that means a lot of ballast. And for track workers, not for the cost, but for the owner cost of hybrid lines, the satellite application, if there is coverage, is a lot of saving. It's clear that you transfer the cost on board because you need a good fusion sensoring, but this is a never-ending story. The train became more heavy than trackside. The car became then heavy than before. So I think is parallelism in each transportation mode. that there is a trackside concentrated wireless and many devices with smart intelligence inside.
Okay, we have at least two questions in the audience. I don't know if anyone here on the panel still wants to react to the question from Alberto on one supplier availability and then CBA.
Only short, yes. If we are ready to deliver, yes. We as Hitachi and as Alstom. But we, of course, with the satellite solutions on, we had already a line in Australia that used satellite over ERTMS and virtual balises. Of course, it's not completely compliant with the standard specification because the standard specification is ongoing. So it's only a matter of adaptation. So we are ready to do this. In terms of reduction of the cost, yes, there are a lot of troubles, of course, but the main problem is, in my opinion, is to face the situation at system level. Of course, if we only add to the onboard the satellite positioning device, it will increase the cost. But we need to have a global picture at system level. In this case, we can reduce the infrastructure, we can reuse the, we can have several sensors that can be used also for other features. And so this is, in my opinion, the leverage to decrease the cost. Thanks.
Thank you. I think the panel is eager to answer. Iban, I cut you short. I don't know if you...
I could just add to bring you from GNSS down to Earth. I mean, the reality is that if we are now facing a feasibility study net to data, which will be finishing in 2026, and then we'll have to feed back the requirements for having a system which is interoperable. So we've got a few steps there to say, what about with the algorithm? Would it be standardized? Would it be the same for everyone? Would it only be standardized the basic black box? How we do test it? We are here in SEDEX. How we do test this one so in a manner that can be used? So all my message to you is if we need to reach to 2030, we'll have to speed up.
Thank you. Everyone wants to answer, so it's good. I'm going to just take it in this order, Thomas, and Stefan.
I was just about to say that 2030 is quite late from my point of view when I want to roll them out. I just wanted to address the point of allocating the costs to infrastructure or vehicle side. There is no one against the other. First of all, any cost that we save on the infrastructure side, we are required by law to lower the track costs, so we give it to the vehicle owners basically. And secondly, and more importantly, these are our customers. So I have an interest as an infrastructure manager for them to do well, because then they can run more trains and everything goes better basically. So there is no one against the other. Of course, we have to solve the question of the initial cost for rolling out anything, not only satellite equipment, but also I don't know, ETCS onboard units, ATO onboard units, and all the stuff that's coming in the next 10 years. But we very much have to look at this from a system perspective, not an actor perspective within the system.
So from my side, a number and a different perspective. I think the study showed that cost-benefit analysis of the safe train position, if used with the other features like level 3 or moving block, is around 80,000 per kilometer. So as an integrated railway, as we are as with Federal Railways, this is a huge number where we can save money. And apart from the other points that we already heard, we have also operational benefits. We have such a dense network with very short headways that we are not able to sometimes maintain the lines without cutting them totally down. And if you have a lot of assets on the track and one breaks down, you have to close down the whole line. If you have a train, the equipment doesn't work, you remove the train and the line is still working for the rest of the trains. So you have a more reliable system.
Well, yes, thank you, Thomas. I subscribe to this approach. This is 2 points, let's say. 1 point, this is the CBA, the cost-benefit analysis performed by the ERTMS user group, the localization working group from the ERTMS, with involving ERFI, SBB, Deutsche Bahn, and SNCF, which shows exactly the figures mentioned by Thomas. And if we focus just on the balise, without, let's say, removal more than just the balise, let's say we were around 7 to 12 kilo euros per kilometer. But I think at the end, it's just not just a question of money, capex, opex, and the unbalance, let's say, between air use and IMs. It's also a system-wide approach where the system can benefit from it. And I think we should be beneficial. The air use, the operators, and the IM should have benefit of this system-wide approach of localization as a service system. I am a guy from the CBTC before going to mainline. I was in mass transit, and I see that in the 20 years of mass transit progress in CBTC, there are 2 cornerstones: C for communication and L for localization. We could say CLBTC, the communication localization based train control. And I can just see the benefits from the operators. The operators in the mass transit, they are not separated. IM, air use, they are RATP at SNCF, in Paris, for instance, they are doing both. And the benefit is energy saving at the end. It's traffic regulation, it's track monitoring, it's maintenance, and things like that. So localization is an enabler, and I think we should get out of this enabler the best. Of course, capex, opex, it's nice to take, we take it, and the IM take more than the air use on this side. We have to work on the onboard side, on the sensors. We mentioned inertial, we mentioned GNSS receiver, and the cost can be a shrink, let's say, to something acceptable to the air use. But at the very end, I think air use must also have benefit from it, with passenger information, with maintenance, with ATO and energy saving, and things like that. Thank you.
Thank you. Let's take the next question.
Thank you.
Sorry,
just a question to Thomas to check if I understood properly. Yes, you. If I well understood, you are committed to reduce the track access charges for railway undertakings that will use rolling stock equipped with the satellite.
I'm not only committed, but I'm required by law.
It's not what has been done with ERTMS. So you would be keen to do it for satellite.
I would, and I'm not only committed, but I'm required by German law. If the costs from the infrastructure side go down, we have to give those savings to the rooms. So this applies to satellite, this applies to ETCS, this applies to everything we do.
Yes. I'm very sorry, but we won't have time to take all of the questions, but there's enough of time afterwards for...
Yeah, my question is towards the suppliers. I naturally represent also an infrastructure manager, and the question is, we are all talking about modular onboard devices and architecture, and what is your willingness in terms of suppliers in order to support this approach? Because it effectively means that shooting in your own knee, because modular onboard architecture means there are many players in the market and there is a competition, and nobody likes competition, to be honest. So the question is pretty straightforward. Your willingness and the approach you would like to follow so that your business business is not at risk. Just if you can give some perspective, it would be grateful. Thank you.
Okay, thanks. Okay. The onboard is already modular. We have already a block that has standard interfaces. The hot topic is the level of modularity. Of course, as a supplier, we would like to maintain a certain level of modularity and not go deeper in them. But this is a matter of also system pillar that we are facing inside the EUROPS-Rail. Yeah. So this is mainly the controversial situation.
I would nearly say the same. So there are already a certain level of modularity. After that, there are also some market requirements. When we have to install a 3 STM in a train and there are little homes, so if we can have a modularity at the application level, it's good as well. Some will say, is it modular or is it modular? We do not want necessarily to increase the level of modularity for doing the same of what is already done today. We have effectively ERTMS plans which are quite ambitious, so we should capitalize on what we have. But of course, for everything which is new, like innovation or what we are discussing on the satellite position, yet there is a need of modularity in order to make sure that effectively interfaces are standardized and we can bring effectively to the global community the result of the new innovation.
And finally, what I can say from our side, there is a clear push from our customers to do it. That's the reality for us. So when you ask me what is the real enhancement from us to integrate this such a technology, is because there is a real push from our customers to do so. We take our customers seriously, and then we try to develop and give them as much as we can. So I don't really agree with that. We do have modular, but we do not have interoperable odometry system in ETCS. That's the reality. And now we are working towards a section which we want to extract the odometry from ETCS, and that's not for free. And that actually brings issue with the Belize reader, with the BTM. It has some requirements that it depends on the odometry. There are some dependencies in system that has been taken different manner for each supplier, and we will have to discuss those in the next 3 years.
All right. Jorge.
Okay. I have a last question, a question for Fabio and perhaps the suppliers, because you defended the virtual Belize approach and the others the enhanced odometry. Don't you think, and perhaps it's a question also for the agency responsible, that both solutions could be included in the TSI? They are not exclusive. They are trying to reduce as much as possible the number of balises. Do you think that both solutions could be included in the TSI?
Balise and enhanced odometry, you mean?
Yeah.
It's clear that the enhanced odometry, it's what we expect without GNSS. So in each mode the enhanced odometry are coming, we are happy. The concept of virtual balise is something more, because you can have when the protection level of satellite is permitted, another linking. So in our point of view, I don't know which is at the end the TSI finally, because we are together in 27, so we have to respect the majority. But in our perspective, in our experience, the virtualization of the linking is something more than enhanced odometry. So are two concepts of the same story, protection level of satellite, but when you want to discriminate which track is, for example, the Kluk 2 is going there, you have to need something very near of linking, which is the next balise that the movement authority describe. So, but is on charge of EUSPA, so I don't want to add more technically.
Maybe I can give you a hint, kind of a news from X2Rail 5 finishing shift to rail. Lea is him. Basically, one of the proposals that you mentioned, we used to have in shift to rail two of the options. One it was enhanced odometry called, and the other one it was virtual balise. What we have proposed in this shift to rail engine, and it's not published yet, but it will be published soon. The idea is that we have a modular system working as a localization system for absolute positioning, and then we have a modular box which is making the virtual balise trigger to the ETCS. This is part of the discussions. We have multiple infrastructure managers in order to integrate the functionality of a continuous positioning system into ETCS with the lowest impact. The moment we do not want to have we are willing to have more impact, we could have all the solutions. But at the moment, I can tell you one of the proposals that we are having, of course with some details which are different, we are really approaching into a single solution in which integrating an absolute positioning system into ETCS using the concept of virtual police might be the most desirable one.
And on this note, thank you very much, Ivan. In order for you all to have the opportunity to have a break, I'm going to take the executive decision to stop the panel now. But I would like to thank you all for your contribution this afternoon. Thank you for listening. Stop. Coffee is ready outside. Please be back here at 5:10 sharp. Thank you. Enjoy. Good afternoon.